Hello, health champions. Today we're going to talk about what really happens to your brain when you eat sugar. Even though dementia is something that mostly happens to older people, we have to understand that that process that leads to dementia started when they were still young. So the big question is, how do we stop it before it starts, and what are the real causes of dementia? Plus, at the end, I'm going to show you how an older, forgetful brain can learn from something that babies do. Dementia is basically a form of brain degeneration, when some of the things the brain used to do don't work so well anymore. And the brain depends on producing energy and processing information and sending messages and signals to the different body parts. But if you can't do that so much, it comes down to two broad categories of causes. And the first one is called toxicity, and the second one is called deficiency. So toxicity is when there's something interfering. The brain tries to produce energy and send signals, but something's interfering with those signals or the energy production. And deficiency is when the brain has to have something that is not provided, or that the brain for some reason doesn't get access to anymore. So there's a lack of resources. And even though there are many reasons why this could happen, I want to show you in this video how sugar is strongly involved in both of these forms of damage. The most common form of dementia is called Alzheimer's. And one of the hallmark signs is called beta amyloid plaques. And this is in the extracellular tissue where you have these damaged proteins that they clump together and create plaques, and they interfere with the activity of the brain. The second sign and hallmark is called neurofibrillary tangles. And this is inside the cell where you're supposed to have small, smooth, straight fibers basically. Because of the degeneration, they start bunching up and getting tangled. So now that brain cell doesn't work so well inside or out. And the problem with diagnosing this is that the final diagnosis can only be done post-mortem, that you don't really find these unless you open up the person after they die. There are many causes for dementia. There's genetics, there is lifestyle, our choices and what we eat and what we do. And poor lifestyle choices can create inflammation, which is very damaging to brain tissue. And if we have brain trauma, if we have traumatic brain injury, concussions, then that can damage a little bit of brain tissue, which creates inflammation. And if all is perfect, then that can resolve. But if we have repeated brain trauma, now that inflammatory response can become chronic. Stress contributes to dementia because it changes blood flow in the brain. And age is perhaps the strongest influence of all because these things happen mostly in late age. Very commonly, we also hear about coexisting conditions as being a cause or a risk factor. But to me, it's not a cause because these conditions are a result of lifestyle choices and inflammatory responses and stress, and not the least, insulin resistance. Now, when it comes to sugar, we have to understand sugar makes every one of these worse. Okay, it's going to express our genetics less favorably. It is the biggest component of a damaging lifestyle. Sugar causes inflammation. Sugar prevents the healing of traumatic brain injuries. Stress makes us eat more sugar, and sugar accelerates aging. And every one of these coexisting conditions, as well as insulin resistance, are made worse by sugar. And we might go as far as to say that sugar is the primary cause of most of these coexisting conditions. But there is a strong genetic component to dementia, and especially Alzheimer's. There is a gene called the ApoE4. And it predisposes a person. It doesn't guarantee that a person will get dementia, but it predisposes. So if you have one gene of the ApoE4, which 25% of the population has, you increase your risk of Alzheimer's by 2 to 3 times, 2 to 300%. And if you're unlucky enough to have 2 genes, which 2 to 3% of the population has, then your risk increases by 8 to 12 times. So it's a dramatic increase. It's not just a few percent. But here's the takeaway, that even if you have both of those genes, it doesn't guarantee that you're going to get dementia, because there's a lot of people with both genes who don't get dementia. And the sooner we can make some good changes, the better off we are. Here's a study that suggests that the Alzheimer's disease starts long before. It's underway long before there are any evident plaques. So in cancer, they often talk about different stages. Same thing here. You have many years before it's even detectable, and then you have stage 1, 2, 3, and 4, where it's pretty much too late. Well, the same thing holds true here, that once you have full-blown Alzheimer's, that's like the equivalent of a stage 4 cancer. So Alzheimer's like stage 4 dementia. You don't want to wait until it's all too late. So let's look at one way that sugar actually damages the brain. Here they talk about how advanced glycation end product contributes to the formation of these amyloid plaques that are associated with Alzheimer's. And these glycation end products, called AGEs for short, they result from a spontaneous and non-enzymatic glycation. What does that mean? It means that it doesn't require anything particular. It doesn't require any resources or energy or enzymes. It happens by itself if we have protein and sugars side by side. Then they're a little bit sticky, so they're going to stick, and when the glucose sticks to the protein, that's called glycation, and it damages the protein, and that's part of the mechanism of how these plaques occur. And then they go on to say that these sugars include the glucose that we have everywhere in our body. That is the blood glucose that we're talking about, that breaks down from every form of carbohydrate that we eat. And that this is the primary energy source for the brain. Now notice, they did not say that it's the only or the exclusive energy source for the brain. But a lot of people are still under that impression that the brain has to have glucose. It has to have glucose. If the brain is feeling a little bit low on energy, then you have to give it glucose. But the brain can run on glucose and ketones. And maybe it's a good idea to balance those a little bit, which we'll take a look at later. Another study says that these beta amyloid plaques are neurotoxic. They're like poison to nervous tissue, and that they're responsible for Alzheimer's disease. And this study went on to show that even though the regular beta amyloid is neurotoxic, if the beta amyloid is also glycated, then it's even more toxic. So it's pretty clear that sugar damages the brain and contributes to dementia. But despite that, this information has not reached the mainstream. Even though some of those articles were 30 years old, they're still mostly regurgitating the old dogma. They're mentioning these same risk factors that I talked about. They say that some of these risk factors, like age and genes, can not be affected, which is kind of true. You don't change your chronological age, but you can change your biological age. You can't change your genetic makeup, but you can change your genetic expression quite a bit. And then they went on to talk about some of the things that you can influence, and these seem completely random to me. They're talking about high blood pressure, and they're talking about lack of exercise. But first of all, there are very few mentions of those factors you could change, but they also seem totally random. I want to know, what is it about high blood pressure that's bad? And that is because it indicates it's a result of poor metabolic health. And what is it about lack of exercise that would be bad? What is it about exercise that's good for the brain. So if we learn some more about the mechanisms, now everything comes together into a simple picture that we can act on. If we just keep pulling random items out of the blue, then we'll just compare one list to another and we'll get more and more confused. And even though this article went on for several pages, when I did a search on the page, search and find, there was 0 mentions of blood sugar, 0 mentions of blood glucose or insulin. So the key factors that we know are involved with metabolic disease and dementia, there's no mention at all. And when I searched for sugar, it showed up twice, and both times it was about diet. And again, we get regurgitated the same old stuff we've heard a million times, that you need to limit your intake of sugar, which is a great idea. But then they bundle that together with limiting saturated fats, not knowing that those two things have an exact opposite metabolic effect. And then they throw in, of course, that to make sure that you eat plenty of fruits and vegetables and whole grain. So again, 0 mentions of sugar, and they're not realizing that these grains are going to turn immediately into glucose, which stimulates insulin and makes the whole thing worse. And another thing that struck me was when they say current evidence suggests that a heart-healthy diet can also help protect the brain. And they're saying that as if there was a possibility of it working any other way, as if there was a way to eat something that was good for your left hand and bad for your right hand, as if you would sacrifice one organ for the benefit of another. It doesn't work like that. If something is good for you, it's good for you. The body cooperates. The cells work together. So I started saying that sugar contributes to both toxicity and deficiency. And I think that pretty much demonstrates how sugar is toxic. But here's the confusion for a lot of people. How can sugar create a deficiency in the brain if sugar is the primary fuel? And that's what we're going to talk about next. And it takes a little bit of looking at a few different steps, but Alzheimer's is often called type 3 diabetes because there's such a close link between dementia and poor metabolic health. So whether we talk about type 1, 2, or 3 diabetes, what they all have in common is that their glucose is out of control. So they all have very, very high levels of glucose. But where they're different is that the reason for that glucose is very different, or at least not the same. So in type 1, the insulin is very, very low or typically non-existent, and that's why that glucose is out of control. But for both type 2 and type 3, we have both high glucose and high insulin. So while type 1 diabetes is kind of its own entity, type 2 and 3 are sort of the opposite. The glucose is high because the insulin isn't working, and we've abused the system over many, many years until the insulin doesn't do the job anymore. So when we talk about type 3 diabetes, we're not really saying that it's a separate, distinct type, because it's not a separate disease. They're just trying to illustrate that how closely related it is metabolically to type 2 diabetes, that when we look at them with different blood markers and the mechanisms, then they're pretty much the same. So it just lets us know that it is the same issue. One of the key factors in a healthy brain is to provide it enough energy. And one of the biggest problems with dementia and Alzheimer's is that the brain isn't getting enough energy. It's starving for energy, and then it starts degenerating. The brain is about 2% of your body weight, but it uses 20% of your energy, 20% of your calories, 20% of your oxygen. And that means that on average, your brain tissue is about 10 times more energy hungry than your average body part. But as if that wasn't enough, there's an area called the hippocampus that is very much involved with memory function, and it's one of the first places to go when people have dementia and Alzheimer's. And this particular area is even more dependent on energy. It's 2 to 3 times more energy hungry than the surrounding brain area. So if the memory function is that dependent on energy, then we have to make sure that we provide that energy, or we're going to have some degeneration and memory loss. And herein comes the big problem, because when we hear that the brain only uses glucose, or glucose is the primary fuel, the first thing people think of is now we have to raise the blood sugar. If the brain is starving, let's feed it some sugar. And why doesn't that work? So here's how it works. We have a blood vessel that has a certain amount of blood glucose. And in order for that glucose to be delivered into a cell, such as a liver cell or a muscle cell or a brain cell, we need insulin. And interestingly, not so many years ago, they believed that the brain did not depend on insulin to receive the glucose. They said that the glucose will get into the brain no matter what, but that was incorrect, and only very recently did we learn that. So glucose needs insulin to get into the cell. So there's like a little gated channel, like a little door, and with the help of insulin, then that door opens and the glucose can get into the cell. But if the liver and the muscles and various different tissues become insulin resistant, then that insulin doesn't open the door as well as it used to. And that can also affect the brain, so the brain becomes insulin resistant. And now we may have lots and lots of blood sugar, but the brain is still starving because insulin is high and the tissues are insulin resistant. So interestingly now, there is a form of fuel that we talked about. We have glucose and we have ketones that can fuel the brain, and the ketones have no problem at all. They have free access. They do not require any help to get into the cell from insulin. So we have a fuel, a backup fuel, if you will, that can still fuel the brain and give it energy. And here's a super interesting article that talks about just that. There was some research headed by Stephen Kinane, and they talked about, can ketones be like a rescue fuel, a backup fuel for an aging brain? And they found out, first of all, that when people had mild cognitive impairment or Alzheimer's dementia, then this glucose uptake, just like we talked about, it didn't work. The insulin wasn't capable of delivering the glucose because the cells had closed the gates. And the reason that that happened, of course, was like we talked about, the insulin resistance. When the insulin is resisted, it can't do its job. And even though we have lots of glucose, the uptake doesn't work. And when they finished the study and reported the results, they found indeed that if they could raise the ketones, if they could get them some MCT oil that breaks down into ketones, if they could give them a supplement with ketones, with beta hydroxybutyrate, which is the primary ketone, or if they could fast them to the body made its own ketones, either way that they could raise ketones, they improved cognitive function. So if they gave them a memory test or some other mental task, then they performed better after they received some ketones. So basically they restored the fuel supply by giving the brain something else besides glucose. And they found this to work both with mild cognitive impairment and with Alzheimer's dementia. So obviously if you have full-blown Alzheimer's, you're not going to get back to normal, but they did better with the ketones than without. And also, they did it with what they called experimental hypoglycemia. So they take a normal healthy person with normal glucose, they give them an insulin shot, so they artificially push the glucose to a super low level to where they get lightheaded and confused. And then they give them ketones, so they're not supplying any more blood sugar, but they get some ketones, and now their brains start working again. So what does this mean for you as an individual? If you don't have dementia yet and you'd like to keep it that way, it's that even though we've been told forever that glucose is the primary fuel and super important for the brain, which it is, it doesn't mean that more is better. It's the exact opposite, that high glucose level, an excessive supply of glucose and carbohydrates creates insulin resistance. And the more insulin resistance we have, the less fuel is available to the brain. And therefore, if we want to catch this as early as possible, we need to understand how and where insulin resistance starts. And if we look at glucose, we miss the point. And if you have an individual with a healthy glucose level, healthy and stable, and they are insulin sensitive, so they just need a little bit of insulin to keep that glucose in control because they eat real food, they eat protein and fat and vegetables, so they have minor blood sugar swings and very stable glucose. They're insulin sensitive and their brain can use all that glucose. There's no resistance, there's no limitation there. But then if we go 5 more years and we haven't learned anything, we just eat processed foods and sugar and soda and donuts and all of these different things that promote poor metabolic health. Now, in 5 or 10 years, we may still have roughly the same glucose levels. So does that mean we still have the same amount of fuel available to the brain? Not necessarily. If during that time we have become more insulin resistant, then our insulin levels are up. And it requires 3, 4, 5 times more insulin to keep that glucose in check. Remember that glucose is a controlled variable. The body needs to keep it, and it will make as much insulin as it has to for as long as it can to keep that in check. But if we're increasing the insulin, we're becoming insulin resistant. And then probably the brain is also becoming insulin resistant, and this glucose is not fully available as fuel anymore. So this brain is starting to starve. It's starting to degenerate. And the process of dementia has already started, even though there may be 20 years before we have a clinical diagnosis. And if we go a little bit longer here, and let's say that we keep eating standard American diet or standard Australian diet, I heard is also SAD, or if we eat the standard UK diet, that's my favorite, suck, then we're not going to make this any better. And our glucose is still somewhat controlled, but it's starting to slip into the pre-diabetic or diabetic range. And now we may have insulin levels that are 8, 10, 15 times higher. And now we are very insulin resistant. So even though this glucose in the blood is higher, we are not providing fuel for the brain. And we never make any ketones because the insulin is going to shut ketones down completely. So like we said, dementia doesn't happen overnight, and neither does insulin resistance. It is something that develops over time as we push our bodies into a maladaptation, as we force the body to adapt in a way that creates insulin resistance. And there is a simple test. It is very inexpensive, relatively speaking. It's called fasting insulin. And if you fast overnight, you draw your blood and they check your insulin. Now you have a really good idea of where you are, because If it's around 10 or 15, you know you're moderately insulin resistant. If it's 25, but you still have decent glucose, you know you're one step away from diabetes, and it's easy to do something about it to reverse it. So if you haven't done it, then ask your doctor that you want the fasting insulin on your next test. It's one of the best predictors for dementia. And maybe we can learn something from babies' brains here. I find it absolutely fascinating. The adult brain is 2% of our body weight, but the newborn is 10% of the body weight in the brain. And while adults use 20% of our total energy, the baby uses 60% of all their energy goes to the brain. And on top of that, they have a tiny, tiny little blood volume, and they're born hypoglycemic. So there's virtually no glucose available for that enormous brain. So what do? Well, obviously, they have to rely on ketones. Without ketones, we would never have been able to develop these huge brains. And while adults have to fast or eat a ketogenic diet with extremely low carbohydrates, the baby doesn't even need to do that. During their fetal period and while they're newborn, about 30% of the brain's fuel come from ketones, even while they're being fed. So I find it fascinating that in the very beginning of life, and for many people toward the end of their life, the brain has this enormous energy need that just isn't supplied by glucose alone. And that's where ketones come in for the rescue. So maybe that means that even between the beginning and the end, there is maybe a little bit better balance between glucose and ketones than just purely glucose. If you enjoyed this video, you're going to love that one. And if you truly want to master health by understanding how the body really works, make sure you subscribe, hit that bell, and turn on all the notifications so you never miss a life-saving video.